Hey guys, could you imagine that we're already at Burmans and in less no time we're gonna be celebrating Christmas again? What's up with that?
Totally. And it's weird because we still haven't gotten through this pandemic.
Well, I mean, it's true, but we still have to celebrate Christmas, right? We need to remember the true meaning of it, which is
the birth of our personal Savior, Jesus Christ.
That's true. We may not be celebrating it like we used to, but a simple Noche Buena with some virtual gatherings and some Christmas lights would do.
And speaking of Christmas lights, I actually kind of discovered this new one from, I don't want to say it, but Shopee!
A new one? What do you mean? I never thought our Christmas lights to be new.
Yeah, we've literally been using it for, wait for it, centuries.
Yeah, I meant it's new because it only uses 90 volts of electricity, which is a lot different from the commonly commercialized ones that uses 120 volts. So it just means that we could literally save up some money in paying for our electrical bills. Isn't it great?
It actually is, but how many resistors does it have? Does it have any?
Yeah, of course. Well, as a matter of fact, it's stated right here. It says here that it has 3 resistors, and ooh, they've got details, by the way. Each resistor has 75 ohms, 26 ohms, and 40 ohms, which are connected to each other and uses a voltage of 90.
I'm just curious, since that it applies 90 volts, I kind of want to know how much voltages it uses through each branch.
Ooh! And I also want to know the total current of those combinations you just mentioned.
Okay, those were a lot of interesting questions, really, and yeah, I think we just have to know it ourselves. What do you think?
That's better. I think I could help.
But before we answer those questions, let us first learn some terms and concepts associated to our later calculations. Resistance. It is the position force experienced by the flowing electrons in some substances. This supposes the flow of electricity in a material. When a current of 1 ampere flows through a material that has a potential difference of 1 volt across it, then the resistance of that material is said to be 1 ohm. The basic law for measuring this is Ohm's law. According to this law, the current flowing in this material is inversely proportional to its material when the voltage is constant. This law is expressed as V equals to I times R, where V represents the voltage or the potential difference across the material, I the current flow of the material, and R the resistance offered by a material. Okay, now that we're talking about Christmas lights, which is known for their use of series circuit, let us now discuss the laws of resistance in a series circuit. For the first law, it states that the current passing through each resistance is the same as the current passing through the combination. For the second law, the sum of the voltages across the different resistances is equal to the voltage across the whole combination. And down to our last law, the third law states that the total resistance of the combination is equal to the sum of the separate resistances. Now that's it, let's proceed to our calculations.
A group of young people have discovered a new set of Christmas lights. The set Christmas lights consist of 3 resistors, 75 ohms, 26 ohms, and 40 ohms, which are connected into series circuit and has a voltage of 90 volts applied through the combination. These people seek to know the following. First, the voltage through each branch, and second, the total current in the combination. So for the given values, we have a total voltage of 90 volts. The first resistor has a resistance of 75 ohms, the second resistor has a resistance of 26 ohms, and the third resistor has a resistance of 40 ohms. Then, we are asked to find for the values of the first, second, and third voltages and the total current in the combination. So, to find the total current in the combination, we have to apply the formula total current equals total voltage over total resistance. But we cannot get the total current because we only have the value of the total voltage. So first, Let's find total resistance. In a series circuit, the total resistance is equal to the sum of the values of all the resistors in a circuit. So R sub t equals R sub 1 plus R sub 2 plus R sub 3. 75 ohms plus 26 ohms plus 40 ohms is equal to 141 ohms. Hence, the total resistance is 141 ohms. We can now find for the total current in the combination. To solve that, we have the formula total current equals total voltage over total resistance. 90 volts over 141 ohms is equal to 0.64 amperes. Hence, the total current in the combination is also equal to 0.64 amperes. Since according to the law of a series circuit, the total current of the combination is also equal to the value of the current for every branch. The total current is equal to 0.64 amperes. Hence, I sub 1, I sub 2, and I sub 3 are also equal to 0.64 amperes. Next, we have to find the values for the first, second, and third voltages. The formula we will use is voltage equals the product of current and resistance. To get the values for every branch of the voltage, we have different values given for each resistor with the same amount of current. Hence, to get the first voltage, we have to multiply the value of the first resistor and the value of the first current. 0.64 ampere times 75 ohms equals 48 volts. Hence, the value of the first voltage is equal to 48 volts. Next, to get the second voltage, we have to multiply the value of the second resistor and the value of the second current. 0.64 ampere times 26 ohms equals 16.64 volts. Hence, the value of the first voltage is equal to 16.64 volts. Lastly, to get the third voltage, we have to multiply the value of the third resistor and the value of the third current. 0.64 ampere times 40 ohms equals 25.6 volts. Hence, the value of the third voltage is equal to 25.6 volts. Going back to the law of a series circuit, the total voltage of the circuit is equal to the sum of the voltages of each branch. To check if we got the correct answer, let's add the values of V sub 1, V sub 2, and V sub 3. So 48 volts plus 16.64 volts plus 25.6 volts equals 90.24 volts or 90 volts.
Ooh! So, to summarize, we first solved for our total resistance, in which we just added up the given values of our resistors, 75 ohms plus 26 ohms plus 40 ohms, and it helped us came up with an answer of 141 ohms based on the given values.
Right, and since that we already had the value of our total resistance, we then proceeded into solving for our total current, in which we just divided our total voltage to its total resistor and gave us an answer of 0.64 amperes or 64 hundredths amperes.
Correct. After we got those, we then proceeded into calculating for the voltages of each branch through multiplying the given values of the currents and resistors.
The first branch, which is addressed as V1, got an answer of 48 volts, which means that it uses 48 volts of electricity.
For the second branch, which addressed as V sub 2, get an answer of 16.64 volts, which means that it uses 16.64 volts of electricity.
For the third branch, which is addressed as V3, got an answer of 25.6 volts, which means it uses 25.6 volts of electricity.
And when we added up those values, we came up with an answer of 90 volts, which is exactly the amount of voltage the Christmas light need in order to light up.
That's it. I think I'm going to purchase that same Christmas light now.
Me too!
Me either.
Oh, don't forget about me.
Oh, what? I'm actually ordering right now.
Same, I already ordered 10 boxes.
Well, I've already got mine.